Wildfires are a devastating force of nature that can destroy forests, wildlife, and human lives. They are also a major source of air pollution and greenhouse gas emissions that contribute to climate change. In Europe, the fire season of 2023 has been one of the worst in recent history, with more than 1.5 million hectares burned across the continent, affecting Greece, Italy, Spain, and other countries. One of the ways to prevent and manage wildfires is to map active fires using remote sensing technologies such as satellites and drones. Mapping active fires can provide timely and accurate information on the location, extent, intensity, and behavior of fires, as well as environmental conditions that influence them. So, in today's tutorial, we'll be using NASA satellite data to map active fires in some of the parts of the world. What's up, friends? This is Milos. Welcome back to my channel as I take you on another geospatial and data visualization journey with R. This time, you will learn how to create effective and powerful animated fire maps using NASA VIIRS data. So in today's tutorial, first of all, I will show you where the data lies. Second, I will show you how you can build a query to communicate with a NASA API and load the data directly into R. And third, I will show you how you can make that a very cool animated map of fires for southern Italy. Welcome back to R, guys, where first of all, we will load the packages that we need for this R session. So first of all, let's define a list of libraries that we need. The first one is the umbrella library called VIIRS, which we will use here for data wrangling and data visualization. The second one is data table, from which we will use one of the functions to read delimited files, such as active fire maps, directly from the URL link that we will build. The third one is ggmap library, which has background and street view layers from Google Maps and OpenStreetMaps. And in this tutorial, we will cut one of those background views and then use to plot in ggplot2 in order to show, where these fires are occurring. And finally, we will also create an animated map. So for that purpose, we'll be using ggAnimate package. Now that we have the list of libraries that we need, we first of all need to check if these libraries are installed on our system. So we're going to create this installed libs object, which is going to, based on this libs object that we created, going to loop through the row names of installed packages on our system. And once we do that, we need to install those packages that are not present. So we're going to write here an if-else statement. So if any of installed libs equal false, in other words, if they're not present, then we need to install them. So we're just going to say here install dot packages. And installed packages is the R function that is used to install packages. But here we need to tell exactly what we want to install. Well, we want to install libs, but only those that are not among the installed libs. That's why here we have this exclamation mark. And then the final stage is simply to load the libraries. And loading is, again, applying the function, which is called library. Function library in R is used to load packages. So we want to apply this function to this libs list of libraries. And this is how you install and then load the packages in R. In today's tutorial, we'll be getting information on active fires from NASA VIIRS website, which collects information about anomalies, terminal anomalies detected by satellites, which helps then decision makers, scientists, and users who are interested in monitoring fires around the world. And this NASA data is based on two satellite instruments. One is MODIS, which we used actually before for mapping land cover data, and the other one is VIIRS. So this website is the starting point, and there are two actually types of data that you can download. One is this archive download data, which basically takes you into previous years. But in this tutorial, I want to show you active fire data for the near real-time or almost real-time data for the past 10 days from the freshest point in time. And if you click here on the active fire data menu and then choose global, it will take you to the page where you can learn more about that. So here, there are of course quite a lot of information, and if you scroll down, you will see that there are different ways to access the data. One of them that we are interested here is this API-area. So if you click on this one, it will take you to the page where you can actually build the query to communicate with the API and then get the points for activiers for your specified area. So we're not going to be getting the data directly from this user interface. This is simply to show us how we can build the query. So one of the very important things here is to be able to communicate with this VIIRS API, you need to have this map key. And in order to get this map key, you need to register first with the Earth Data service. And to do that, you can follow one of my previous tutorials where I explain step-by-step this process. How do you do that? So once you register, you'll be able to have this map key and you will be able to build a query and then get the data for your area of interest. Now, about the things how to build a query. If you scroll down, what you will see here is how the query should look like. So not actually the first one, but the second one. So how do you build this? You build on top of this main link, which is viirs.modapps.eosthis.nasa.gov. You then add this to it. Now, you do need to specify here some things. So in your link, you need to build this map key. So this is where you will add your map key. Source is going to be the satellite that you will be using. And we can refer back to actually this part, which shows us what are the available ones. For our purposes, what we want is this VIIRS SNPP, which is ultra real-time or near real-time, so both. This one has the freshest data from my experience, and it's the most useful one. So that's the second thing that you need to add to your web link. Then you need to add area coordinates, but very importantly, we can see here how they do it. So you start with the west. West is basically minimum longitude, so X-min. And then it goes into Y-min, and then X-max and Y-max, exactly in the order that we have. But very importantly, this should be added so their commas are separating each of the coordinates. So that we want to make sure that we also have that in R. And then there are two final components, which is day range. So this is how many days of data you want to get. And this service specifically gives you data for the 10 days range. But what's 10 days? And this is where you specify date. So date here is a start date. So the date from which you want to take the data. So in most cases, what we have here is data is lagging by 2 days. So today is 22nd of August. So for the data starts or ends with the 20th of August, which means if I want a 10-day range and it starts or ends with 20th of August, I probably need to choose 10th of August here. So all in all, this is the information, the only information we need for the API part. So for the area, we need the bounding box coordinates. So I'm here at this website, which is called bboxfinder.com. And this one allows you to actually draw a bounding box around any area you want. So you simply need to go to the left-hand side and then click on this draw a rectangle button, which is fifth from the top to the bottom. You click there, and then what you can do is you can simply draw here a bounding box. So for southern Italy, this is the one that we want to draw, just like this, and then you release once you're ready. So what will happen next is that in the lower left corner, you will see something which is called box. And it has these 4 values. So these are basically the coordinates of this bounding box that you just drew. So what you need to do next is simply copy these coordinates. They are in WGS 84, and then we will use them next in R to define our area of interest, which is southern Italy. All right, so we copied here the coordinates. Here they are. Now we need to make sense what they actually are. So the first one is actually the minimum longitude value, which is denoted by X-min. And here I'm just going to go for the first decimal. So I'm going to go for 11.4. The second one is the minimum latitude value, so denoted by Y-min here. And again, I'm just going to go for 36.6. The third value, which is 18.7, let's round it to 18.7. This one is the maximum longitude value. And then the final one is the maximum latitude value. So this one is roughly, let's say, 41 degrees. So this is the first step. The second step is we need to put these into a list, and I'm going to call them area chords. So area chords And then in order to put them into lists, you need to open the brackets and then put C in the front. That's how it's done in R. And then we just need to order them in the order of appearance. So it goes first with X min, and then Y min, and then X max, and finally ends with Y max. So now that we have the list of these coordinates we're going to be using for fetching the area, the final one is that once this is done, of course, it's going to be in the shape of a vector list. So without any kind of commas in between those different points, but we want to have the actual commas. So otherwise, NASA is not going to be able to recognize these. So what we're going to do is we're going to create an object called area. And then what we're going to do is use the paste argument from R. And simply we're going to separate these area chords by those commas. So the separator will be a comma separator. And they are going to be collapsed again also by the comma separator. Alright guys, let's start building our query. So we're going to actually create a function which is going to be called getFireData. And then within this function, we're going to specify all those objects that we need. So the first one is going to be the main URL, which you could paste from the website directly. The second one is going to be the map key. This one is of course specific to your username and your registration, so you should use it here as well. The third one is the satellite source that we'll be using. The fourth one is the area. The fifth one is the day range, and finally the last one is the date. So these are the elements of the function that we want to define. Now we open this curly brackets, and within this one we then specify how this URL should be built. So we here create the URL object, and then we can use a paste function from R in order to glue all these elements together. So we will need exactly all of these things, so we're just going to put them here. And most importantly of all is once we do that, each of these parts, like in every good old HTML link, should be separated by dash. So here we need to specify that this is going to be the separator for this case. Alright, so now that we have these thingies, what we can do next is simply define, of course, this URL and how we're going to fetch the data. The thing is, this will help us get the CSV file, which is comma delimited file, directly from the URL. And this is where data table kicks in, which allows us to read this from this URL directly, this comma delimited file directly into R. So we're going to create a new object, which is going to be called FireData, and then we're going to call data table and its function, which is called fRead, and we're going to read this URL that we created. Alright, so after this, we simply need to return the main object of this function, which is called just FireData. Alright, so for our function to work, we need to specify each of those elements and then build this URL. So the first one, as we said, is the main URL. So this is the URL that we copy from that main firms page, and this is how it looks like. So it's https and then firms modapps eos.this.nasa.gov API area, and then importantly CSV. So this is the main one. Then you need to here define your map key. This is also very, very important. Of course, here I'm not going to read my own, but it should be defined here as a string. The third element is the source. So this is the name of the satellite that you're going to use. Again, it's defined as a string. And as we said, it's going to be VWIRS and then underscore SNPP and then underscore, it's going to be near real time. So NRT. Okay. So we already have area coordinates. We don't need to define them. What we need here is actual day range, and we're gonna here go for the maximum day range, which is 10 days. Be careful here to define this as a number and not as a string. And then finally, for dates, as we said, we want the date which is the start date. So it's a date which is not gonna be the last date. And for that, we can simply use sysdate, which is going to be just simply system date, so today's date. And then we can just deduct from it 11 days. So this should give us 10th of August, given that today is 22nd of August. All right, now that we have all these elements, what we can do is we can call this function called getFireData. And by calling it, we can create an object called FireData. Now, within this getFireData, as we said, we need to specify several things. So the first one, as we defined, is the main URL, and we defined it also as main URL. It's here. That's the first one. The second one in our function is a map key. Again, this one is the one that you get with your registration. Then there is a third one, which is source. So we also define source as source above. Then the fourth one is area. So this is one that you need to have, and area is defined as area. So we calculated this one before. Day range is simply the number of days that we want. And finally, the last one is the starting date, which is defined by date. All right, now that we run this, we should be able to get the data frame with point coordinates for the fire data for Southern Italy region. If you follow all the steps so far, you should be able to get this line which is downloaded and then the number of bytes, which basically means, yeah, we downloaded the data. What we can do next is we can inspect this fire data. Let's say we just inspect the first few rows so that you can actually see, what are the columns here that we got. We can also inspect the number of rows, but for now, let's see what is out there. So the first thing is, of course, that is latitude and longitude. And there is something which is called bright TI4 and later on bright TI5. So this is basically just what is the temperature of this thermal anomaly as measured from the satellite instrument itself. This does not mean that this is the intensity of fire, but it could be used potentially to calculate. What we will use in this tutorial is this bright TI5, which is in kelvins, and we're just going to turn them in Celsius. It just shows you how this anomaly, the temperature of the anomaly on the satellite instrument. So we're just going to use that as some proxy for intensity. But again, it's not really the intensity of the fire. Then we also have some other things here. One of them is the acquired date. So this is, the date available. So the first one is, as we can see, 11th of August. That's the first one, and it should go all the way to the 20th of August. There are some other things here which are not so important. One of them is the instrument, exactly the one that we chose. There are also here confidence levels, but they're also denoted by this bright TI5, and also whether it's day-night or nighttime when this was taken. All right, mostly what we will use here is only 4 fields, basically latitude, longitude, acquired time, and this bright TI5 to denote the color of them. We can also check how many of these observations are here. So we can just here type this and go for the number of rows. I'm very curious. Okay, so that's actually a lot of fires in Southern Italy. So that's 1.2K, quite a lot, guys. As I said in the very beginning, we also want to have some kind of a background layer so that we know what are the regions or maybe even places in Italy that are struck by active fires. So for that, we can simply use ggmap and get one of the street layers it has. So we're gonna go ahead and create this bg_layer and call ggmap. Now you can use Google Maps or OpenStreetMaps. I personally like this Stamen map, which is from OpenStreetMaps. Here we need to first of all define the bounding box, denoted here by bbox, and for that we need to use that area chord, so the first vector one that we had. For the zoom level, so this is how much detail you need to have. You need to be careful here. The maximum one is 12, but you should go lower than that because the higher you choose, the more tiles it will need from these online services to compile this layer that you need. So here I went for 7. And then you can go here for the map type. So I would like to go for the terrain one. There are more than those. So there are also street views. There is without lines, with street lines. I would go for the terrain. And then the terrain, the default one is going to be in color. But I would like it to be black and white. So here what you can do is you can select that the color is black and white like this. So color equals BW. And then, because this is not a default option, you should also use force equals true, so that it forces ggmap to download this layer. We can also check how this layer looks like. So we can call ggmap and then again ggmap, and then simply pass this bg layer. And then once you run this, you should be able to see something like this. So it should be black and white, it should be terrain, but it should have some of the labels for the region that you chose. Before we jump straight into making map, let's define the theme that we're going to use. And let's call it triumphantly theme for the win. We're going to be defining this as a function, which means that we're going to be simply calling this ggplot attributes here. And one of them is theme void, which is going to help us to get rid of any excess material in the background. But because I want to customize some additional thing, I'm going to call here also this theme. And one of the things that I want to customize is the legend position. Here, I would like the legend to be on the right-hand side. Another thing that we could change, and I definitely want to do that, is, for example, the legend title. Here we are dealing with the text, so you need to make sure that you tell ggplot2 that this is element text. Now here you can, for example, define the size, and this is in pixels. So we can go for the 12 size, and we can, for example, go for the charcoal gray. In a similar vein, we can also define other text that will appear, and one of them is, for example, legend text. So this one can be the same, we'll just, make it a bit smaller. Apart from this, we might also want to have a title and a subtitle. So let's start with the title. So title is, again, an element text, and we're gonna go for a bit bigger title compared to the legend title. So the plot title can be, for example, of the size, let's say, I don't know, like 16. The color can be still a charcoal gray, but I would like to horizontally justify it. And to do that, I'm going to choose here 0.5. Apart from this, we can also define the subtitle. We just need to change here from plot title to plot subtitle, because this one is going to show dates that are changing with every frame. We want it to stand out a bit. So first of all, we're going to make it bigger. We're going to choose 24, and then instead of charcoal gray, we're going to go for something flashy, like, for example, fire brick. It can be horizontally justified, so that's fine. But one other thing that we can do here, we can, for example, make the letters bold. So this is going to also add more to this accent. Apart from the title and subtitle, we can also create a caption. So here we can define how big the caption is going to be. We can just go for the 10 size. We can make it a bit lighter gray. It can be horizontally justified, and we probably want to keep it on the bottom of the plot. Apart from defining text, we can also define some other things, and one of them is, for example, the plot margin. So plot margin helps you actually shrink or expand the margins of the plot, which is exactly what we need. And this one is defined as a list of arguments for all of the 4 sides. So for example, for the top side, we can shrink it. Right hand side, we can keep it as is, given that it's going to have also the legend on the side. For the bottom side, we can shrink it even more. And then for the left hand side, maybe we can expand it just a bit. So once this is defined, we also need to specify what types of units we're going to use for working these plot margins. And we can finally write the code in ggplot2, which will create, first of all, a static map, and after that we can also do the animated map. So the first things first is making sure that that dates column is the actual date. So we're going to go back to our fire data, and we're going to create a column called datum. And then we're just going to declare what we have as dates. And what we have is called eq underscore dates. So we're just going to run this just to make sure that we are working with dates. All right. The next thing is to write, of course, the code in ggplot2. So we're going to create an object called t here. And the first thing is to add that ggmap layer. So we're going to here call ggmap. And we're going to plot here that bg underscore layer. So in ggplot2, if we are using this ggmap layer, you don't need to specify ggplot. So this is going to be your main one. The next thing is we are of course working with the data frame and we're working with points. So we need geom points argument in ggplot2. Within geom points, the first thing is to specify the data. Data is of course fire data. And of course, this is going to be, apart from this layer, the main aesthetics. So that's why I use here AES and the open brackets. In aesthetics, you define the things that are gonna change. They are variable. And one of them are the X and Y positions of the points. So the X one is of course a longitude, while the Y one is a latitude column from the data frame. Of course, there are more things that we can do, and one of them is we can color the points. And for the color, as we said, we can use that one which is called brights_TI5. Now, these are in kelvins, and in order to transform kelvins into Celsius as we want, we need to subtract from this kelvins 273.15. So that's how it's done. Then finally, one more last thing is we want to group all these appearances by dates. We do that because what happens when you animate without grouping them by date is that they kind of tend to fly all over the place, and we don't want that. We want this animation to be very stable, and with every change of the frame to have new points added. So for that reason, we're going to group by date. And finally, but very importantly here, because we operate with two aesthetic layers, we don't want to inherit anything from this BG layer. In other words, we want to allow points to be mapped on top of this layer. After we are done with defining the layers, we can go ahead and define the colors that we want to use. And for that purpose, we are going to call this argument scale color gradient. We're doing that because we're here working with continuous measures rather than discrete. The first thing is we can define the title of the legend. So we can say here brightness, and then in R, if you want to create a new row, you just do this /n. This is how it's done. So brightness, temperature, and then again we can use /n, and then here you can just say Celsius. Or if you don't want to use this very long, you can just type degrees Celsius like this. And then for the second argument, you can define the colors that we can use to denote the temperature of this thermal anomaly. And I like to use hcl.colors, which include VIIRS and a bunch of its very, very cool palettes, which very much so are good for showing the fires and fire data, because they have this very, very bright colors, and one of them is the Inferno palettes. So I'm going to use here, let's say 6 values from this Inferno palette, and because I want lighter values to be associated with higher values, I'm just going to reverse this palette like this. Alright, so once this is defined, we can finally call also our theme for the wind that we define, and very importantly, you need to define here with open brackets because we are calling a function. The final step is to define the labels that we're going to use through the labs argument. One of the labels is of course the title. So here we can specify that we're showing wildfires from 11th to 20th August 2023. And then here in the caption, we can also say that the data used is from NASA firms. And then very, very importantly is the subtitle part, because this one is going to be the date, which changes with every frame. And here we need to put it in a specific format so that GG Animate can grab it and then use it to create the time-lapse map. So you need to open these curly brackets, and then you need to open the normal brackets. Within normal brackets, you need to declare here frame time, which is simply a constant, or like a variable name, I would say, not a constant, but a variable name. And once again, you need to declare here that we are dealing with the date, so as date. Once we created this ggplot, which is going to produce a static map, we're ready to animate it by adding more layers using ggAnimate. So first of all, we're going to create an object called time-lapse map. And then this one is going to work on top of that P object that we just created. So the first thing that we need from GGAnimate is to declare what is going to be our transition time. And the transition time in our case is the date, and not any date, but it's that datum column that we created. So that's the first thing. The second thing, in this tutorial, I would like to create a cumulative plot, which means that as every point shows, it's going to stay and new points will be added as the time passes. So to do that, you just need to here again call GGAnimate and then shadow underscore mark and then open brackets here. There are other options that you can specify, but for now, we just want to make this plot cumulative. That's all. We can then add some additional effects, and one of them is, for example, when the point enters the scene, we want to maybe make it fade into the scene. So to do that, we can use GGAnimate and then enter underscore fade. What you can also do here is, for example, apart from entering by fading in, it can also be exiting the scene by fading out. So here you can also define exit underscore fade. Now, apart from these things, GGAnimate is cool for one more reason, and that is because you can choose the animation style that you want to apply. So how animation is actually going to proceed. So that one is managed by ease AES. In other words, how are you going to ease the aesthetics, right? So here you need to define your style. GGAnimate has a lot of different styles, so you can check them out. The default one is linear, but since we're dealing here with points, I really found that cubic in and out, which is based on a cubic function, really helps those points stand out as they appear and as they leave the scene. And finally, you can also choose how fast this is going to be. So the interval here denotes seconds. So 0.25, it's going to be pretty much not so fast, not so slow. If you want to make it faster, you decrease this. And if you want to make it slower, you increase it. So once we have this time-lapse map, we're ready for the final stage, which is going to be animating based on all these options. So we're going to create an object called animated map. And this one is going to work on the top of this time-lapse map. But first of all, we're gonna go ahead and call GGAnimate again, and it's option animate. Within this one, we need to specify what we're animating, so we're animating this time-lapse map. And then there are several things. One of them is the number of frames. So number of frames, I think 60 is gonna work for us here, since we don't have actually that many dates. We have 10, and I think 6 frames per date is going to be just fine. Sometimes when you have actually more dates, you need to choose more frames. Duration is going to be the duration in seconds, and let's choose, for example, 12 here. Though, given that we have 10, we could easily go for just like 10 seconds, but I just want to give it a bit more time, given that we are also going to start with a pause at the beginning. So this is defined by start underscore pause. And I'm going to give it here a few seconds just for that. And then because it's very nice that the last frame is frozen so that you can see all those bar points, what you can do here is you can define also the end pause. An end pause can be even 10 times longer than this. There are other things that you can specify, of course, width and height. I like to work with inches, so I'm going to specify here in inches, but you can also do it in pixels. So I'm going to go and say that the width and height is going to be 7 inches each. If you want to change units, it's managed by the units argument. And because I'm using inches, I'm going to specify here as a string in. Other things here include also the resolution. So I can, for example, use the resolution of 300 pixels. You can also choose frames per second. So here I go for 15, which is a bit higher. The default one is 10. Very importantly, if you have a lot of dates here that you want to animate, maybe it's better to actually decrease these frames per second below 10. And then finally, we need to choose the renderer for the scene. And the best one is the GIFSKey renderer, where we can also define here that we would like to loop this GIF that we're gonna create. If you follow all the steps so far, in the end, you should be able to see this message. So inserting images and then encoding to a GIF. The one last step is simply to save this into a GIF. So again, you call ggAnimate and then anim_save. And here, first of all, you can write your file name. So we can say fire southern Italy and then .gif. And then here the object that you want to save, which is animated map. And here it is, ladies and gentlemen, the wildfires map of southern Italy for August 11th to 20th, where we actually show a cumulative rise of fires, and boy, there are so many of them. They do smoothly enter the stage, and you can see that they fade in, but as they enter the stage, they do stay in the stage. So maybe the fade out argument is not necessary after all, since we're doing the cumulative one. But you can see also on the sides the legend, so clearly this gives you an impression about the thermal anomaly temperature in Celsius. There are of course ways to improve this map, whether it's in terms of the color, whether in terms of the background, but this is how you can start off your own projects and create similar maps for your own area of interest. And that's all for today, folks. In today's tutorial, you'll learn how to animate fire maps using NASA firms data. We created an animated fire map of southern Italy for the last 10 days of available data, but I'm really looking forward to your own use cases and how you can take this tutorial on a journey across the world and show us some very important snapshots of active fires. If you would like to replicate this analysis, I prepared a link to the GitHub repo in the description below. Feel free to clone it, reuse it, modify it as you see fit, and produce something very cool. If you're new to R and you seek to expand your knowledge of R, I prepared a few very cool tutorials for you, so do check them out. And also, if you have any questions, comments, or feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. See you next time.